Next, we're going to find the equation passing through the point -2, -7 and parallel to the line 10x plus 2y equals 7. This is the first time that my equation is not in slope-intercept form. So first thing, I'm going to find the slope. And again, I'm wanting not just any old slope, I want the parallel slope. So I'm going to write my equation, 10x plus 2y equals 7. It's not in slope-intercept form this time, so I need to do a little bit of work to get it there. I'm going to move the 10 to the other side, and when I move it across the equal sign, it changes sign. Divide everything by 2. I get y is equal to -5x plus 7/2. So my slope is -5. But that's not the slope I care about. I want a parallel one. So because it's parallel, I know the slopes are equal. So my new line is going to have a slope of -5. So I use the slope that I just found and a point in order to get an equation using point-slope form because I have a point and a slope. So I'm going to rewrite my m as -5 here. My point, I'm going to write in black, -2, -7, which is my x1, y1. And then I rewrite my equation. The more times I rewrite my equations that I have to memorize, the easier they are to memorize because you've already written them a lot of times. So we have y minus y1, which is -7, equals m, which is -5, parentheses x minus x1, which is -2. So I'm going to distribute to clean this up to make it put in slope-intercept form. So -5x, and -5 times a +2, because you add a line, change the sign, that's -10. Add a line, change the sign here, that's y plus 7. Lastly, I subtract 7 from both sides. I'm getting y equals -5x minus 17. Next, we're going to find horizontal and vertical lines that are perpendicular and passing through a point, or parallel and passing through a point. These are actually pretty easy, but again, pretty easy to mess up because there's not really much work to be shown here. So we are going to find an equation passing through this point, x1, y1, but perpendicular to x equals 4. Now, because x equals 4 only has one letter, we know that's one of those special cases. We know that because this is a VUX problem, that x equals 4 is a vertical line. So instead of doing all of the work that we could possibly be doing in the last couple problems, these are way easier because it's a special case. I know that x equals 4 is a vertical line. So if I know it's a vertical line, what is perpendicular to a vertical line? Well, a vertical line is perpendicular to a horizontal line. So I know my answer is going to be a horizontal line because horizontal lines are perpendicular to vertical lines. And the equation of a horizontal line is always, let's see, that's a Hoy problem, y equals some number. So all I really need to do is figure out which number to use. Just like we did a little bit earlier, I'm just going to pick my y value, and that's going to be my answer. Very, very simple. Because it's perpendicular to a vertical, it's horizontal. Horizontal is y. Let's do this again several times because it's really, there's not much to it. But again, when there's not much to it and there's not a lot of work to be shown, sometimes that almost makes it a little bit tricky because you can't get partial credit or anything. Okay, so we need to go through 4, 8 on the next problem. Again, we're perpendicular to y equals. Now, y equals is a Hoy problem, isn't it? Which means it's a horizontal line. Now, what is perpendicular to a horizontal? So I'm a horizontal. What's perpendicular to it? Well, a vertical. So a vertical line is the equation is going to be, well, that's a VUX problem, isn't it? X equals some number. So which number is it? Well, I go back to the only numbers I have that I have to pass through. I have to pass through the point 4, 8, and because I'm looking for the x value, it's x equals 4. On the next two, we have, again, more special cases, and you know it's a special case because the equation is only x equals a number or y equals a number. So on this next problem, it says find the equation passing through negative 1 comma 5 parallel to x equals 3. Now, x equals 3x, that's a VUX problem. So x equals 3 is a v vertical line. But this time I want parallel to a vertical. So let's say I'm a vertical line here. What's parallel to me? Well, another vertical line. I know I want another vertical line, which again is still VUX, so my equation is going to be x equals some number. Which number is it going to be? Well, looking at your two values, the negative 1 is the x value, so it's x equals negative 1. Okay, so on the last one we have y equals negative 7, which is a HOI problem, which is a horizontal line. So because it's a horizontal line, I need something that's parallel to a horizontal line. What line is parallel to a horizontal? Well, if I'm a horizontal line, parallel to me would be another horizontal line. So what's horizontal? That's a HOI. So my equation is going to be y equals some number. Which number is it going to be? Well, you go back and look and you've got y equals negative 3. So that's an example of every single type of special case. Perpendicular to both a horizontal and a vertical, and then parallel to a vertical and a horizontal. So just to give you a little bit of a shortcut, if it says perpendicular, for special cases, the variable changes. If it says parallel, again for special cases, the variable stays the same. Now, if you get the correct variable, then all you have to do is go back and pick the correct number that is associated with your variable. So as soon as you get the correct either x equals or correct y equals, then the rest of it's pretty easy. So let's go back through real quick and check these. This says perpendicular, so my letter was x, it changed to y. This says perpendicular, my letter was y, it changed to x. On the next two, it says parallel, so this was parallel, my letter was x, it stayed x. So parallels, the letter stays the same. This is y, and it says parallel, then the letter stays y. So I hope that little shortcut helps you out.